All right, so in this video, I want to go through Fundamental Theorem of Calculus Part 2. This is how we actually evaluate an integral when we're not doing the derivative of an integral. So it says if f is continuous at every point on a closed interval a to b, then when we talk about the antiderivative, capital F, we're going to do the antiderivative of little f at b minus the antiderivative of little f at a. And we did that in part of our proof in part 1, but now we're going to actually work backwards. So we're going to start with this one. Now, some of you did these in pre-calc, some of you did not. So I want you to think about the power rule when we're doing an antiderivative. We're saying the derivative of what function equals x cubed plus 1. Now, when we did the derivative, we took the exponent down, we multiplied by the exponent, and then we subtracted 1. So when we do the antiderivative, we have to work backwards. Instead of multiplying by the exponent and subtracting 1, now we're going to add 1 to the exponent and divide by the exponent. So to do that, our antiderivative, our capital F of x, is going to be x to the 4th divided by 4. And then what function has a derivative of 1? Well, that would be x to the 1st divided by 1. So I don't have to write all of that in. Now, usually we would have to put like a plus c here because I could have any constant out here. But this one is called a definite integral. And I want you to write that note here. This one is called a definite integral. And it's called that because you've got limits of integration. You've got a -1 and a 3 here. So we're going to evaluate this from -1 to 3. And if you recall in our definition up here, it says to evaluate it at b first, then a. So we're going to plug in the 3 first. So we get 3 to the 4th over 4 plus 3 minus -1 to the 4th over 4 plus -1. So when I plug this into my calculator, 3 to the 4th over 4 plus 3, I get 23.25. And when I plug this in, I get positive 1/4 minus 1. So I get minus -0.75. So 23.25 plus 0.75 gives me a total of 24. So now, the only difference between finding an antiderivative and evaluating an integral and finding area is that your 3rd grade teacher wasn't so crazy when they told you area can't be negative. Actually, it was probably 5th grade that your teacher told you area can't be negative. So here it says to find the area between the graph and the x-axis over an interval from a to b, it says we're going to have to cut the function wherever there's a 0. So we've been talking about how when we integrate, the area below the x-axis is negative. But when they specifically use the phrase find the area, we can no longer consider that amount of space as negative. It has to be considered positive. So I want us to look at this function, 4 minus x squared. It's a parabola that opens down, and it starts up at the point 4. So go ahead and draw the graph. And they're looking from 0 to 3. So I'm going to starts up here at 4. Actually, I'm going to want to so this is at the point 0, 4, and it crosses at the point 2, 0. And then out here at 3. So you'll notice when we talk about integrals, area underneath a curve, we're talking about from the curve to the x-axis. So that's right there. And then over here, from the curve to the x-axis goes up. So that's this area. Don't draw weird triangles under here. It's from the curve to the x-axis. So what I want you to see is that you have negative area and you have positive area. But according to our rules, we can't have area that's negative. So if they want us to find the area, it says cut it off at the 0. So my 0 is at 2. So that means I need to do the area from 0 to 2 of 4 minus x squared. And then the other area was from 2 to 3. From 2 to 3 of 4 minus x squared. And it says to add the absolute values of those integrals. The only one I really have to absolute value is the one that's negative. So this is the area I'm concerned about. So first off, let's find the antiderivative. So the antiderivative of 4 is 4x. And the antiderivative of negative x squared, we add 1 to the power and divide by the power. Same antiderivative over here. The function didn't change. Just over here, we're going to go from 0 to 2. And from here, we're going to go 2 to 3. All right, so if I plug in 2, we get 8 minus 8/3. And then we get 0 minus 0. So 8 minus 8/3 is 5 1/3. Over here, if I plug in 3, 4 times 3 is 12, and then 3 to the 3rd divided by 3 is 9. So I get 12 minus 9, which is 3. And we already know we plugged in 2 earlier, and we got 5 1/3. So 3 minus 5 1/3. This is obviously going to be a negative 2 1/3. So we get 5 1/3 plus this negative 2 1/3. But remember up here we said we don't have negative area. So we're going to take the absolute value of that. So we get a total area of 7 2/3. Now, the difference is if I had simply asked you to evaluate the integral of 4 minus x squared from 0 to 3, you would not have done the absolute value here. So then you would have ended up with an integral value of 3. So if it tells you to integrate, and I'm going to even write that over here, if they asked you to integrate, you would have gotten an answer of 3 because it would have taken the positives and subtracted the negatives. But this one said find the area, which means we had to absolute value anything that was negative. Your area is always bigger than the integration. All right, last but not least, a reminder, you can do these on your calculator. So to numerically integrate this function where they wanted you to do the area, here's the trick. On your calculator, you can put in fnint and then just put in absolute value of the entire function, comma x, comma a, comma b. That will make sure you find the area. Take the absolute value away and you'll get the integrated value. So I want you to do that for example 6. I want you to do the fnint. If you have the old syntax, fnint, you're going to go to the math function, and there's an abs button of x cosine of 2x. And you're going to have to close those parentheses, comma x, comma negative 3, comma 3. And if you punch all that in, I'll pause the video, you should get 5.425. Perfect. Nice work.